Here we go with some probability questions, you guys. This is the probability section of the final exam review packet. Up first is number 27. So remember when we did binomial expansion stuff and we had this weird formula, and if you didn't want to FOIL b minus a to the 9th, there's a shortcut way to do that. So you could use Pascal's triangle if you're looking at your notes packet for chapter 3, which was probability when we did this binomial expansion stuff. Or you could use the formula, probably faster than writing out 10, because the first row is 0, 10 different rows in the triangle. And so first of all, this question is very confusing. You're going to see something almost identical to this on the final though, so listen up. Find the coefficient, which just means the number in front of all the B's and A's. How did I get that? So first of all, if you notice, like when you FOIL this, the B would go first because it's written first in the binomial. And so what I did is I changed this a to the 6th, b to the 3rd to b to the 3rd, a to the 6th. So for some reason it's like out of order. It's like that on the final too, you guys. So just know that that means that it's the 3rd exponent on b. So if you would start counting down, when you FOIL this, the first thing would be b to the 9th, then b to the 8th, 7th, 6th, 5th, 4th, 3rd. This means that I'm looking for the 7th term, and that 7 is what I'm going to need to help me use my formula. So I had to first figure out, okay, what term number has a to the 6th and b to the 3rd in it? So I started writing them out. b to the 3rd is the 7th term. 1, 2, 3, 4, 5, 6, 7. Okay, so in the essence of using the 7th term, that means you use r equals 6. So remember, it's minus 1. It's for the same reason as the triangle starts in row 0, but pretty much. So if it's the 7th term, I'm going to use r equals 6, and that r is used in this formula. This formula you should have memorized, but n is the exponent number, so that's 9. Since I'm foiling it like 9 times, that means that the n is 9, and the r is going to be 6 since I'm looking for the 7th term. So 9 choose 6 is in your calculator. It's probably under the math button. There's a probability section, and that's where like your factorial and your NCR and your NPR is. This is NCR, so choose. 9 choose 6 gives you 84. And then you take b to the n minus r, and it's b because that's the first thing in the trinomial. So b to the n minus r happens to be b to the 3rd, but hey, I already knew that. Like b to the 3rd was in the answer. And then negative a to the 6th. So be careful, whatever sign this second thing has gets plugged in for this second or third parentheses here in this formula. So if this is a negative sign, then keep it negative, and that means it's negative a to the r is 6, so that goes here. And so yeah, that negative squares away, but hint, hint, if this is an odd exponent, your answer is going to be negative. Okay, that should make sense, but memorize this formula, and then that's just a brief introduction and, recap on how to do those. And so 9 choose 6 is essentially what the question was asking you to do. And so 9 choose 6 in the calculator, NCR 9, NCR 6 is 84. Okay, so moving on, I'm going to flip to the next probability section, which is if you just flip the page one time. Let's get to those cards examples. So I should hopefully be able to go through these pretty quickly, but the probability that you pick a face card. So a face card is a card that has a face on it, kings, queens, and jacks. There are 4 of each of those in each suit. That means 12 out of 52, which is 3 out of 13. Black card and face card. Well, how many blacks are faces? So how many of those total face cards are black? So that's just half of them. 6 out of 52. So 6 of the cards are both black and face out of the total deck. 6 out of 52. Okay, black or face. Okay, so this looks like an N to me, so that really reminds me of and. This is a U, that's or. That means you have to add the black cards and the face cards and subtract any of the ones that you counted twice. So all of the cards that were counted in the black category and the face category, there are 6 cards there that are both black and face that you counted twice. So count all the black cards, all the face cards, and subtract the ones that you double counted, and that gives you 8 out of 13 when you reduce. Probability that it's not a face card. Well, if you know that 12 of the cards are face cards, then 52 minus 12 leaves you with 40 not face cards, and that reduces. 35, how many license plates can be made with 5 numbers followed by 2 letters? Has to be, or an even digit cannot appear in the first 3. So notice I wrote odd, 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 because those all have to be odd. And the letters may not repeat, but I'm going to assume that means that the numbers can repeat. So all 5 numbers are odd, so 0 through 9. Odd numbers, there's 5 of them. Second one, it can repeat, but it still has to be odd. Third one, it can repeat, but it still has to be odd. And then these last 2 can be any digit, so there's 10 digits there. And again, they can repeat, so 10 and 10. Letters may not repeat, so the last 2, 26 options of letters, and then I can't use that again, so 25 options of letters. Okay, how many 3-digit, wow, this license plate one will continue to come back and haunt us. No repetition of numbers, 3-digit, even numbers, so there's a lot going on in this. So put your 3 slots for 3 digits, even numbers. So here are my choices of numbers to use, and you can see that 0, 2, and 4 are even numbers. So that means I'm going to start here. I have 3 choices for that even number. And whatever number goes here out of 0, 2, and 4, I'm doing that first. I cannot repeat this number here, which is why this number is a 4. There's only 4 options left after I pick the even number to go here. And then again, I can't repeat again, so this one goes last. So I choose a number for here out of only 3 choices. I only have 4 choices here since I can't repeat, and then 3 choices here since I can't repeat. That's the first part. Now what you have to think of, what if one of these numbers that I counted starts with 0? And so the reason why you can't assume that like the 0 doesn't go here is because maybe the 0 was here and maybe it wasn't. That's a really complex mathematical calculation. So what we have to do is subtract all the 3-digit even numbers that start with 0. So assume that it does start with 0. That means there's only one choice for this number, which is 0. And then let's go to this even spot. If I already used 0 here, then that means that the options for this number are 2 or 4, so only 2. And then can't repeat, which means only 3 options left. So it's a weird order and a weird way of filling in these slots, I guess. And so then go ahead, type this in your calculator. Remember, you're multiplying 4 times 3 times 3 minus 1 times 3 times 2 gives you 30. Okay, 37 is really basic. If you have a bunch of different options of stuff, you just multiply them together. So how many different outfits? How many ties do you have? How many pairs of pants do you have? How many shirts? How many jackets? Multiply them straight across. Don't forget these formulas, you guys. Remember, the strategy is to start writing out like n minus 6. If you decrease this by 1, it becomes n minus 6, n minus 7, n minus 8, blah, 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 blah. So just put the factorial there. And then the n minus 8s cancel here in the denominator. So it's a little harder with negatives, but just remember that you're always counting down for factorial. And so instead of writing n minus 8, n minus 9, n minus 10 all the way down, I'm just going to put n minus 8 factorial, so it cancels that. And then all you have to do is FOIL this. Okay? Let's go to the next page. Oh, another formula. So you should probably refresh your memory on the choose formula, the NCR. So that means this number factorial goes on the top, this number goes on the bottom with a factorial, and also subtract those factorial. And then you can just leave it like that. There's not really a good way to simplify that, so you can leave it like that. Okay. Number 40, let's see, how many ways are there to pick? So you're choosing, and the order doesn't matter. So you are choosing 5 students. It's not like you're placing them 1st through 5th or anything like that. You are strictly choosing. So order doesn't matter. Choose tells you to use the C. So use the C button in the calculator. Out of 30, choose 5. There's a bajillion different ways to do that. Okay, now let's get into tree diagrams. And so remember, trees usually are used with percentages when you have like given conditions and stuff. And so hopefully you can like read the question and see that it lends itself to doing a tree diagram. You can first decide 16% of people have the wine flu. Haha, get it? That means that 84% do not have the wine flu. So anytime you're given one percentage, you're also given the like opposite percentage. You have to figure that out yourself. Everyone is tested for the disease. Of the ones who have the flu, so in this branch, 82% of them test positive, which means 18 of them test negative. So remember, anytime you're given a percentage, you are also given the opposite percentage. 20% of those without the disease, so this branch not having the flu, 20% of them test positive, which means 80% of them get an accurate negative test. So fill out your tree diagram first, and then all these questions should seem really simple after that. What's the probability the person has swine flu and tested positive? When you go down the tree, you just multiply. So 0.16 times 0.82. You just multiply those straight up. What's the probability a person did not have swine flu and tested positive? So not swine flu is 0.84 and tested positive is 0.2. So again, when you work your way down the tree, you just multiply. What's the possibility of someone testing positive? So we don't know if they had the flu or they don't. There's actually two ways to test positive in this tree. There's two different areas where you have positive tests. So you could either have the flu and test positive, or you could not have the flu and get a false positive. Those are the two different options. So I like to write it out in words first to keep my work organized. The probability of having the flu and testing positive is 16 times 82. Both as decimals. Remember, in stats, or means plus, so the other option for that is to not have the flu and test positive, so 0.84 times 0.2. That gives you your grand total there. What's the probability someone has the swine flu given that they tested positive? So this given thing, you probably need to refresh. So what's the probability they have the flu? So P flu. Given is what the bar is, so given that they tested positive, given positive. So remember that the formula for that is to make this an and, flu and positive. That goes here. Divided by, I like to think about this as my divisor bar. Testing positive is the denominator, so probability of positive. So let's do flu and positive. So again, up on the tree, flu and positive. We already calculated that number. We did it up here, flu and positive, so 0.1312. And then there's actually two ways to test positive. That was having the flu and being positive, or not having the flu and being positive. We calculated that number in 43. So this number divided by this number, just refresh yourself on the formula, you guys. That gives you 4385. Okay, and last page of probability stuff. This question I kind of struggled with at the beginning, reading it, trying to do a tree. I don't know, it was kind of weird because there's an overlap situation. So when there's an overlap, meaning getting an A in both Spanish and English, that makes you think maybe try a Venn diagram. And so you can organize the data here, and my favorite way to do a Venn diagram is to take like my Spanish folder and write the, circle, and write the total, the 42% on the outside of it, because that reminds me that in this entire circle should add up to 42. I'm not exactly sure what goes here and what goes here yet. But the probability you receive A's in both, I have the both category now, is 0.27. That goes here. And since I wrote my 0.42 here, I can come up with this number now. This number minus this number tells you how many are left. And remember that this 0.15 means they got an A in Spanish but not in English, because they're not in the English circle, but they're in the Spanish circle. Probability that you get an A in at least one, that means this number plus this number plus this number is 93. And so that is how I was able to figure out this 51. So if you're given the at least one of the two courses, that means you got an A in Spanish or in English or in both. That still means you got an A in at least one of the courses. So this plus this equals 93. That also tells me, I'm not sure if we will need to know this or not, that 7% out here did not get A's in either. So that's like the excluded category, the people that are not in either of these circles. So now that I have this drawn, these questions should be very simple. Find the probability of getting an A in English but not Spanish. Boom, 51 right there. In the English circle, not in the Spanish circle. Probability of getting an A in exactly one course. So screw these both people and screw these neither people. Exactly one course means only Spanish, so 0.15, or only English, so 0.51. There's where we get 0.66. Probability of getting an A in neither class. Aha, I'm really glad I already filled this out because I knew that there was probably going to be a question about that. If Getting an A in at least one of them is 93. That means getting an A in neither is 0.07. All right, last section. How many ways are there to award first through fifth place? So remember, when you see that word place, you're giving them awards, placing them. You can do one of two things. You can do the P, that means placing first through fifth place. You can do 30 students, place 5 of them, or you can do your little slot method if you want to. You have 30 students to choose from for first place. Then after the first place student has gotten their award, there are only 29 left for second place. Then there's only 28 left for third place. This and this give you the same answer, so you can think about it however you want to. A card is picked from a deck, then replaced, so you still have 52 cards to choose from then. If it wasn't replaced, your number would change from 52 to 51. A second card is picked, find the probability of picking a jack, followed by another jack. So that means jack and jack. So I write it out in words because it helps me figure out the formula and what to do mathematically. But I know there are 4 jacks out of 52, and if I pick one, so that's 1 out of 13 or 4 out of 52. But if I put it back in the deck, still all 4 jacks are now back in the deck. Out of the total, 52 cards are still there. So multiply those straight across. You could also reduce those, 1 out of 13, 1 out of 13. When you multiply those, top times top, bottom times bottom, 1 out of 169. Thanks for watching the stats video, you guys. Hopefully that was helpful. Good luck studying. Bring questions to class.